Okay, so we are going to finish chapter 8.7 tonight. We're going to finish learning about all these special cases. And tonight what we're going to do is factoring a difference of two squares, and in case we have to factor out a common factor first. So the first thing we're going to deal with is a difference of two squares. And what that means is when I look at the problem, it's a difference first of all, subtraction, and then each term is a perfect square. So if that's the case, if it's a difference, now you have to be able to identify that. So if it's a difference of two perfect squares, you're going to do two sets of parentheses. You're going to do z minus, you're going to do the square root of that, minus the square root of that, and then the square root of that, plus the square root of that. So z minus 3, z plus 3. And that's really all you have to do. You can check that by foiling it out, but you're going to see what's going to happen is you're going to get z squared plus 3z minus 3z minus 9. The middle two terms, plus 3z and minus 3z, are actually going to cancel, and you're going to be left with z squared minus 9, which is what you started with. So let's do another example. First, you need to notice it's a perfect square minus a perfect square, so that's a difference of two squares. So you're going to do two sets of parentheses. Square root of the front minus the square root of the back, square root of the front plus the square root of the back. And that's all. You're done. For the second one, it's a perfect square minus a perfect square, so it's going to be square root of the front minus the square root of the back, square root of the front plus the square root of the back. Okay, let's do it again. This time though, the first term won't be 1, it'll be a perfect square. But 16, you should know, is a perfect square. So is 81, so that's still a difference of two squares. You're going to do it the same way. Square root of the front is 4x. You're going to do plus the square root of the last number, which will be 9, and then minus the square root of the last number, which will be 9. Okay, so that's how to factor a difference of two squares. Now, sometimes it's not a difference of two squares, but there is a common factor. So if you'll look at 24 and 6 here, you can factor out a 6, like a GCF, and that's going to leave you with 4g squared minus 1. Now that's a difference of two perfect squares. So you're going to leave the 6 out front, and you're going to factor it just like we've been doing in this whole video. Square root of the front minus the square root of the back, square root of the front plus the square root of the back. Okay? And of course you can always FOIL it back out and multiply it back out and see if you get your question. But I'll tell you right now that this one does. Alright, two more. We're going to factor out a GCF because these aren't perfect squares. So what number will go into 12 and 48? You're probably thinking 4, but there's one bigger. I know 6, there's still one bigger. 12. 12 will go into both of them. So 12, factor that out, and you get 1t squared minus 4. Well, 1's a perfect square, and so is 4. So this is going to be t minus 2, t plus 2. And if at any time you want to do the problem before I do the problem, pause it and try to do the problem. And then you'll be able to check it and see if you're getting the right answer. So like maybe pause it now and try to do the second question, and in a second start the video back up, and then you'll be able to see me do it and see if you got the right answer. Alright, B, you're going to factor out, you don't want to factor that. There's no number that's going to multiply to give you 3 and add to give you 12. So we are going to factor out a GCF between 12, 12, and 3, that's going to have to be 3. So that leaves you with 4x squared plus 4x plus 1. 4 is a perfect square, 1 is a perfect square, and the square root of that's 2, the square root of that's 1, and if you double it you get 4. So this goes back to last night's video. You're going to do 2 sets of parentheses, and this is a perfect square trinomial, so you're going to do 2x plus 1, 2x plus 1. Just in case you don't believe me, let's FOIL it back out. That's going to be 3 times 4x squared plus 2x plus 2x plus 1, which will be 3 times 4x squared plus 4x plus 1. Multiply everything by 3, you get 12x squared plus 12x plus 3, which happens to be what you started with. So your factors are correct. Alright, pause the video, do these 4 guided questions, number 1, number 2, number 3. Make sure you number it like I do. Make sure you show every step of your work if you want credit for it. If you have any questions, you can contact me in any of the ways you see here, and I will see you tomorrow.